Okay, example 17. Here we've got an equation, z cubed plus 4 root 2 plus 4i root 2 is equal to 0, equals to 0. We're just going to rearrange it so it's actually a cube root that we are looking for, and the number that we are going to cube root is minus 4 root 2 minus 4i root 2. So the steps are exactly the same. First, we are going to find the modulus and the argument. So this is going to be 4 root 2 squared add 4 root 2 squared. I just write the positive values because I imagine this is like it's triangle, right angle triangle, looking on at the lengths. Okay, so this is going to be 16 times 2, 32, add 32, square root of 64, which is 8. Argument. Okay, let's just plot the point if you need to, but you should notice that it's 4 root 2 across, 4 root 2 down. We are talking about 45 degrees to both axes. So altogether, it's going to be minus 135, which is 3 pi over 4, minus 3 pi over 4. So I haven't used trigonometry, I just used common sense here, which is fine. So I'm going to use exponential form because that's my preferred form. So z cubed, oh, don't forget to over here add 2k pi, because this will, every single time you do 360 turn, you'll come back to the same position. Okay, so let's write it. It's going to be 8 e to the power of minus 3 pi over 4 add 2k pi I. Okay, so we are going to cube root it. So I'm going to do this one a little bit quicker. So if I raise it to the power of a third, cube root of 8 is 2. And then I just need to multiply the power by a third. So it's a third minus 3 pi over 4 add 2k pi I. Okay, so we've got a choice here. You could put 0 to 1, 2 as consecutive numbers of k. I'm going to try, actually, if I put, I'm just thinking, if I put minus 1 here, well, we could actually try. If we need to adjust, it's actually a good idea to see what I mean by that. So if I put minus 1 here, my first complex number is going to be 2 e to the power of, well, let's think what's the argument going to do here. So it's, you do it on the calculator. I haven't got one handy here. So you're going to times that by 4, so it's 8 pi over 4, which is, okay, Lola, 8 pi over 4, which gives you minus 11 pi over 12. Oh, that's perfect. Don't need to adjust it. The first argument. The second one, if we put 0 into our argument, it's 2 that stays the same. So you are left with a third times minus 3 pi over 4. So it's going to be minus pi over 4. And the final one is going to be 2. Let's put 1 over here. It's going to be minus 3 pi over 4, and then plus 2 pi, and we're going to have a third of that. Okay, so it's going to be 8, take away 3, so it's 5 pi over 4 times a third, 5 pi over 12. There you go. Okay. So if the question, I mean, with those arguments, you won't really be expected to convert them into Cartesian form, or you could, but then you need to do some rounding. But we may have to give the answer in trigonometric form, which is fine. So here's my first one, 11 pi over 12. And then the second one is cos minus pi over 4 add I sine minus pi over 4, and then this one is 2 cos 5 pi over 12 add I sine 5 pi over 12. There you go. And that is our example 17 done. So you are ready now to move on to exercise 1F and enjoy.